All right, let's get started on section 1.1. So we're going to go through exponents, how to evaluate them, order operations, and inequality. So let's go ahead and get started with exponents. So exponents are just a shorthand for repeated multiplication. And so what that means is that instead of having to write out, let's say 3 times 3 times 3 times 3, mathematicians came up with exponents, so we can just write this as 3 to the 4th. And so in this expression here, the 4 is the exponent. And the 3 is what we call the base. So it's really important to know what the base is because sometimes we're going to work with negatives. And we need to know whether or not the negative is included in the base or not. And so that's something we'll see a little bit later in one of the later sections. But let's go ahead and look at a couple of examples. So this first example here, we're looking at 6 squared. And so 6 squared just means we're taking 6 times 6, which gives us 36. And we always want to completely multiply these out if the number is not too big. There will be some cases where if you multiply it out, you're going to end up with a really big number, and we're just going to leave that in exponential form. The second one here, let's say we have 3/4 all in parentheses squared. Since that fraction is in the parentheses and we're squaring it, this 3/4 here is our base, 2 is our exponent. So this means we're taking 3/4 times 3/4. And so if you notice, we're squaring the 3 and we're squaring the 4. That's exponent rule we'll see later. But we end up with 3 times 3 is 9 over 4 times 4 is 16. So exponents, not too bad to evaluate, but we need them for order of operations, which is our next topic here. So order of operations, some of you might remember hearing PEMDAS. And so this is going to help us figure out what order that we want to evaluate all of our different operations in. So the P stands for parentheses. And by parentheses, we just mean grouping symbols in general. It doesn't have to be a parenthesis. It could be a fraction bar, it could be brackets. But we're going to do operations inside grouping symbols first. And we have to be careful because sometimes parentheses are used to show multiplication instead of being used as a grouping symbol. The E here is going to stand for exponents. So after we do everything inside grouping symbols, we're going to go ahead and evaluate exponents. M stands for multiplication. D stands for division. And we're going to do multiplication and division from left to right. And so that just means whichever one comes first. Doesn't have to be multiplication before division. It's just going to be that we do those from left to right. And same thing with these last two, addition and subtraction, are also going to be from left to right. So whichever comes first, from left to right, we're going to do first. All right, so let's go ahead and look at some examples here. So this first one, we have 7 plus 3 times 8. So with order of operations, we do multiplication before we do addition. So we're going to do this part first. And so we're going to have, everything else is going to stay the same. So we still have the 7 plus in the front. 3 times 8 is 24. And then lastly, we just have to go ahead and add those, so we get 31. First one's not too bad. Let's go ahead and take a look at another one. So this next one, we're going to have some multiplication and division. So we have 90 divided by 3 minus 2 times 9. So for this one, remember multiplication and division, we do from left to right, but we have to do both of those before we subtract. So left to right, we'll do 90 divided by 3 first, and you can actually do this division and multiplication at the same time, like you'll see in a second. Let's go ahead and just do the division. So 90 divided by 3 is 30. Keep the rest, so minus 2 times 9. And then we want to multiply those two, so keep the rest. So 30 minus 2 times 9 is 18. And so if you notice, if we would have just done that in this step, 2 times 9 is 18, we could have gone straight to here. But this is perfectly fine. So 30 minus 18 gives us 12. Alrighty, next one here, just so we can see some parentheses. We have 8 plus 2 parentheses, 5 minus 1. So these parentheses here are acting as a grouping symbol. They're grouping the 5 minus 1, and they're acting as multiplication because we're going to be multiplying this by 2. But before we do multiplication, we want to do all the operations inside the parentheses, even though they're subtraction, because they're inside the parentheses, we do them first. So I'll leave the rest. So we have 8 plus 2 parentheses, 5 minus 1 is 4. And so now these parentheses now just mean multiplication. So we're going to multiply next. So we have 8 plus 8, and 8 plus 8 gives us 16. All right, this next one here, pretty similar to that one. We're going to have 7 times 6 minus 3 parentheses, 8 plus 1. So again, for this one, we have parentheses, so we have to work inside there first to leave everything else the same. So we'll bring over the 7 times 6 minus 3 parentheses, 8 plus 1 is 9. And now we have some multiplication here and subtraction. We do multiplication first from left to right. So 7 times 6 is 42. Bring over everything else. Next we have multiplication. So we're going to have 42 minus 27. And then if we go ahead and subtract those, we get 15. And now let's go ahead and try one more of these before we take a look at one with more than one grouping symbol. This one we have 10 minus 3 squared plus 5. And so for this one, we have subtraction, addition, and we also have an exponent. So we do exponents first. And remember, the base here is just the 3. This is a minus sign. It's not a negative 3. So we're going to go ahead and have 10 minus 3 squared is 9 plus 5. And now working from left to right, because we have subtraction and addition, 10 minus 9 is 1 plus 5, which gives us 6. All right. So now these next two examples are going to have multiple sets of grouping symbols. So if we have more than one grouping symbol, which is pretty common when you're doing these order of operations questions. We're going to work from the inside out. So that means we're going to start with the innermost set of grouping symbols and work our way out. So what I mean by that is if we have 9 bracket, and then parentheses 4 plus 8, end parentheses minus 3, end the brackets. We're going to start with the innermost set of grouping symbols, so that'll be these parentheses here. So I'm going to keep the rest the same and just add those together. So 9 bracket 4 plus 8 is 12, and we don't need the parentheses because they're not going to be used for multiplication, so we'll just leave that as a 12. Bring the minus 3 in the ending bracket. And now we're still working inside the brackets. So we do grouping symbols before multiplication. So we have 9 bracket, 12 minus 3 is 9. And now just like parentheses, brackets also work as multiplication. So this just means 9 times 9. If you wanted to just put that as multiplication or switch it to parentheses, that's perfectly fine as long as you know that that's multiplication. And so we end up with 81. All right, so then this last example here is one with a fraction. And so fraction bars are another form of grouping symbol. And so we have 2 parentheses 7 plus 8, end parentheses plus 2, all over 3 times 5 plus 1. And so what we're going to do here is, because this fraction bar here is a grouping symbol, that means that we're going to simplify the top and the bottom separately before we divide or before we reduce that fraction down. So let's go ahead and look at the top. First thing we want to do is simplify this group. So we're going to have 2 parentheses 15 plus 2 all over, and now we can do these at the same time even if you're working on different operations. So on the bottom, first thing we're going to do is simplify this 3 times 5. This is a 1 here. So 3 times 5 is 15 plus 1. And now back to the top, our next operation is this multiplication. So we have 30 plus 2. And if I go ahead and just simplify the bottom, 15 plus 1 is 16. And now before we can start reducing this, we have to completely simplify the top. So 30 plus 2 is 32 over 16. And think again of this as division. 32 divided by 16 is 2. And so these order of operations questions can get pretty complicated, but if you just break them down into their little parts and do it step by step, they're not too bad. All right, so now let's look at the last part of this section, which is inequality. So inequality, just as a review of the different symbols, we have this symbol here. This one means less than. So they always point to the smaller number. And so this one means greater than, because the number on the left is going to be bigger. And then this symbol is less than or equal to, because we have that equal to bar under it. Flip it around and we have greater than or equal to. And then finally, this equal symbol with a slash through it means not equal to. So there's going to be some kind of true and false statements in your homework, and we'll take a look at a couple of them now. But before we do that, one thing that I want to note, and this is going to be really important when we get to solving inequalities where we have variables. If we have something that says 3 is less than 5, so we have this true statement here. This is the exact same thing as if we were to flip these around. So flip the 5 to the left, the 3 on the right. We also have to flip around this inequality so that it's still true. So 5 is greater than 3. So we have to reverse the numbers and the inequality symbol. All right, so let's go ahead and look at some examples, just some true false statements here. So this first one here, we have 28 is not equal to 4 times 7. So some of these we're going to have to simplify a little bit. So if I go ahead and simplify the right side, we have 28 is not equal to 28. Sorry, all of these examples are true or false questions. This is not true. So this one is false because 28 does equal 28. The next one here, I'm going to write this one out, but I'm not going to say what symbol we're using, just so you can kind of try to figure that one out yourself. So we're given 5, and then on the right side, 4 plus 2. So make sure you're thinking about what symbol this is. So I'm going to go ahead and simplify the right side. So we get 5 and then 6 on the right. And so this one is saying 5 is greater than 6, which is not true. We have another false statement. All right, number 3 here, this third example. Again, I'm going to write it out, let you think about what symbol we're using here. This one, there's nothing to simplify. So this one's saying 25 is greater than or equal to 10. It's greater than, it doesn't have to be equal to, so this one's true. Next example here, 21, the symbol, and 21 on the right. Take a look at that one really fast and see if that one's true or false. Because there's an equal to symbol here, since 21 is equal to 21, this is true. Doesn't have to be less than, just one or the other. And then we'll do 2 last examples for this section of examples. This next one, we have 9 times 3 on the left. This is our symbol, and 28 on the right. So we want to simplify the left-hand side, and we get 27 on the left, still 28 on the right. And since 27 is not greater than or equal to 28, this one is false. And now this last example here deals with fractions. This one looks a little bit uglier, but there's a nice way to compare these. So we have 4/7 less than or equal to 5/8. So sometimes just by looking at these, it's easy to tell which one's smaller. If this had been a 1/7, it's pretty easy to see that that's smaller than 5/8. These ones are pretty close, so what we're going to want to do is get a common denominator. And so common denominator for 7 and 8 is going to be 56. So I'm going to change both of those to 56. This one on the right, we have to multiply that by 7, so we get 35. The one on the left has to be multiplied by 8, so we get 32. And now since the denominators are the same, we'll just look at the top numbers. 32 is less than 35, so this one is true. All right, so now this last set of examples here, we're going to be going from words to symbols. So we want to write with symbols. And we're going to be doing this a lot just because this stuff shows up a lot with word problems. So you want to be able to Take a word problem, write it down with math symbols so that you have an equation to solve. So we're just going to get started with it with the inequalities. So this one says 9 is equal to 11 minus 2. And so we're just going to break this down. So 9, the number 9, is equal to symbol, 11 minus 2. And this is all we're doing for these, just writing this equation, don't have to simplify at all. Number 2 here, we've got 17 is less than 30. And so here, just being able to figure out what symbol you need. So we've got 17 is less than, so try writing down the symbol for that one. Should have the symbol pointing to the left, and then 30 on the right. So for these ones, it's really just all about reading it from left to right, knowing which symbols we're using. All right, number 3, 8 is not equal to 10. So again, we have 8, so number 8 is not equal to, so equal with a slash through it, and then 10 on the right. And then let's go ahead and do one more here. 2 is greater than or equal to 2. So first we have 2, number 2 is greater than or equal to, so try writing down that symbol. So you should have a greater than or equal to symbol with the line underneath pointing to the right, and then number 2. All right, so that's it for section 1.1. Next time we'll get started on some algebra stuff. We'll be looking at some expressions and equations.